Okay, I hope I'm audible to all my students who are attending this online lecture for the Intermediate Microeconomics Part 1 course. This course is currently offered in semester 3 of BA Honors Economics at University of Delhi. What students can see on your screens is the 2025 question paper which has come up at Delhi University for Economics Honors Intermediate Microeconomics Part 1 course. Okay, so in this particular online lecture, I'm going to start with the discussion of this exam paper. Okay, it's a 90-mark paper, as students can clearly see on your screens. Okay, the duration of the paper is a 3-hour paper. It contains 2 sections, section A and section B. Okay, out of 5 questions from section A, only 3 need to be attempted, but I'll be solving all questions. And from section B, only 2 questions need to be attempted. So for a total of 5 questions, where every question carries 18 marks. So for 5 questions, you have 18 times 5, which makes it 90 marks. Okay, so in this online lecture, I'm going to start off from the discussion of problems from section A. And in this lecture, we are going to solve question 1, part A, which is a question based on the Slutsky decomposition of substitution effects and income effects, which I have covered in quite depth in my intermediate microeconomics course. Students who are watching this online lecture, please note that just doing the past year papers is not enough. This is going to give you an idea about my teaching style, but to get the complete benefit of this particular course, I recommend all the serious students to join my complete intermediate microeconomics part 1 course. This course is specifically designed for Delhi University students and is going to give you complete knowledge about the kind of topics Delhi University covers for the intermediate microeconomics part 1. Okay, so let's quickly start off from the discussion of question 1, part A in this online lecture. So let's read part A. Suppose a consumer consumes 2 goods X and Y. Utility function is log X plus Y. The moment you look at the utility function, you can see it's a quasi-linear utility function. It's a quasi-linear utility function which is linear in good Y but non-linear in good X. The price of good X is 0.5 rupees, price of good Y is 1 rupee, income of the consumer is 10 rupees. Okay, so we need to find the initial equilibrium of the consumer, then we need to find the new equilibrium of the consumer if the price of X falls from 0.5 rupees to 0.1 rupee. Then we need to bifurcate the total price effect into substitution effect and income effect using the Slutsky decomposition technique. All these concepts are covered in quite depth in my intermediate microeconomics part 1 course, along with extensive numerical practice. Okay, so first thing, let's come to the whiteboard. Let's write the important details of this question. So I hope all students can see the whiteboard. Let's quickly write the main heading for clarity. This is Delhi University. This is economics honors we are talking about. Semester 3. That means this lecture is recommended for second year students. Name of the paper is Intermediate Microeconomics Part 1. This is Intermediate Microeconomics Part 1. And we are discussing the 2025 question paper. So let's look at question number 1, part A. We are given that there are 2 goods X and Y. There are 2 goods X and Y. We are given that the utility function is log X plus Y. Initially, the price of good X is 0.5 rupees. The price of good Y is 1 rupee. And the income of the consumer. So I can just write M. Let M denote the income of the consumer, which is 10 rupees. Okay. First part asks us to find the initial equilibrium. Now it's a quasi-linear function. We know how to plot a quasi-linear function. So this is good X, this is good Y. Our budget constraint is going to look like this. So equation of a budget line, equation of the budget line is going to be xpx plus ypy exactly equal to the income. Expenditure on good X plus expenditure on good Y exactly matches the income of the consumer. If I plug in the values, 0.5x plus Y equals 10. If I plot the intercept, the horizontal intercept of the budget line is, I put Y as 0. So I get X as 10 over 0.5, which is how much? 10 over 0.5 comes out as 20. And the vertical intercept is, I put X as 0. So Y simply comes out as 10. So X is 20 here, a rough sketch I'm drawing, and Y is 10. Okay, this is going to be my downward sloping budget line. And the slope of the budget line is minus Px by Py. In this case, price of good X is 0.5 and price of good Y is 1. So the slope is negative 0.5. Okay. Quasi-linear utility function always cuts the axis of the linear good and is asymptotic to the axis of the non-linear good. I've covered this in quite depth in my theory lectures. So students, please revise my theory lectures again. The linear good is Y, so it's going to cut the linear axis and it will become asymptotic to the non-linear axis. That means my indifference curves are going to somewhat look like this. They're going to look like this. And so on. They are going to cut the y-axis because y is a linear good, and they are going to be asymptotic to the x-axis where x is the non-linear good. Now clearly we can see that the equilibrium will occur somewhere at the tangency point. So that is going to be my initial equilibrium. So I can write at the initial equilibrium, E0, slope of the indifference curve is exactly equal to the slope of the budget line. And I'm ignoring the minuses because everything is in absolute term. So the absolute value of the slope of the indifference curve equals the absolute value of the slope of the budget line. Slope of the indifference curve is marginal rate of substitution. Slope of the budget line is 0.5 in absolute terms. I ignored the minus because IC and budget line both have negative slopes. Anyways, when you equate them, the negatives cancel out. Now, what is MRS? For this particular indifference curve equation, the marginal rate of substitution is marginal utility of good X over marginal utility of good Y. This is nothing but partial derivative of the utility function with respect to good X over partial derivative of the utility function with respect to good Y. If I partially differentiate the function with respect to X, I get 1 over X, because the derivative of log X is 1 over X. And if I partially differentiate with respect to Y, del U by del Y is just 1. So my MRS is only 1 over X. So I can write here that 1 over X is equal to 0.5, which implies that X is equal to 1 over 0.5, which is, I can write 10 over 5, which is 2. When X is 2, I can plug this in the budget line equation to find what is Y. So remember, my budget equation is this: 0.5x plus y equal to 10. So putting x equal to 2 in the budget line, because my equilibrium should lie on the budget line. Putting x equal to 2 in the budget line, which is 0.5x plus y equal to 10. This is my budget line equation. Okay, put x as 2. 0.5 times 2 plus y equals 10. So this is 10 plus y equals 10. So I get y as 0. That means the initial equilibrium of y I'm getting is 0. Okay, so let me make a correction here, students. 0.5 times 2 is 1. Please correct this. There's a mathematical error. 0.5 times 2 is 1. So I get y as 9. That is why I was wondering, we can't get 0 as the answer anyways, because it's a tangency point. It's an interior point. So please make this correction. 0.5 times 2 is 1. So 1 plus y is 10, which gives me y as 9. That means at the initial equilibrium E0, the values of x and y are 2 and 9 respectively. Now, at the new equilibrium E2, or I can write E1, at the new equilibrium E1, what is going to be the new price? The new price Px dash is how much? Income of the consumer is still 10 rupees. Price of good Y is still the same. How much is the price of good Y? 1 rupee. But price of X changes, right? How much does the price of X become? In the question we were given that price of X, if I come back to the question paper, see the price of X falls to 0.1. That means the new price of X is 0.1. So coming back to the whiteboard, price of X, the new price of X Px dash is 0.1. Price of Y is still the same, which is 1. So my new budget line equation will be, the new budget line equation is going to be X Px dash plus Y Py equal to M. If I plug in the values of Px dash and Py, it's 0.1x plus Y equal to 10. The new slope of the budget line is going to be, the new slope of the budget line is going to be minus Px by Py, which is going to be minus Px dash by Py. Now Px dash is 0.1, Py is just 1. MRS is going to remain the same. It is marginal utility of good x over marginal utility of good y, which is del u by del x over del u by del y, which came out as 1 over x. See, we already calculated the MRS in the beginning, right? And it was coming out to be the same. MRS is 1 over x. So in equilibrium, what will happen now? In equilibrium, in the new equilibrium, at E1, again, the absolute value of the slope of MRS equals the absolute value of the slope of the budget line, is minus Px dash over Py. When I compare the absolute values, 1 over x equals, remember this minus goes away when I take the modulus, so 0.1 over 1. So I get 1 over x equals 0.1, which implies x is 1 over 0.1, which is 10. What will y be? Put x equal to 10 in the equation of the new budget line. So putting x equal to 10 in the equation of the new budget line, putting x equal to 10 in the equation of the new budget line, I get 0.1 times 10 plus y equal to 10. So this means 1 plus y is equal to 10, which gives me y as 9. That means at the new equilibrium E1, the values of x and y are 10, 9. Now let's look at the equilibrium with substitution effect. Now what does Slutsky say? To capture the substitution effect, we calculate the compensated income M dash. We calculate the compensated income M dash such that the bundle at the initial equilibrium, E0, that is, what is the bundle at E0, guys? The bundle at E0 was 2, 9. The bundle at the initial equilibrium, which is 2, 9, is still affordable. If students have attended my lectures on Slutsky equation in detail, to capture the substitution effect, what does Slutsky say? The Slutsky simply says that you calculate the compensated income M dash so that the original equilibrium bundle is still affordable at the new prices. The new prices are Px dash and Py, which are 0.1 and 1. These are the new prices, right? The new prices are 0.1 and 1. So that means my M dash will be what? M dash will be this bundle evaluated at the new price. So 2 times 0.1 plus 9 times 1. What I've simply done is I've evaluated the value of the initial bundle at the new prices, because I want that according to Stutsky, even if the prices change, I still want my original bundle to remain affordable at the new prices. So this makes it 0.2 plus 9, which is 9.2. Now this is my new income. So what is my compensatory budget line? I can write, let me write this more clearly here. The compensatory budget line is, X px dash plus y py equal to m dash, which is my compensatory income I just calculated, which is 9.2. Now px dash was 0.1, py is just 1. So y into py is just y, m dash is 9.2. Now, what is the slope? The slope is minus px dash over py, which is negative 0.1. And in equilibrium at E0 dash. Now, let me call E0 dash as the equilibrium with substitution effect. Equilibrium with substitution effect. So at E0 dash, again, I compare the absolute value of the slope of the indifference curve and the absolute value of the slope of the budget line. The absolute value of MRS is just 1 over x. We've already calculated it before. The absolute value of the slope is just 0.1. So again, 1 over x equal to 0.1 implies that x is what? X is 1 over 0.1, which is 10. Now I put x equal to 10 in the compensatory budget line. So putting x equal to 10 in the compensatory budget line, putting x equal to 10 in the compensatory budget line, we have 0.1 times 10 plus y equal to 9.2, which implies 1 plus y is equal to 9.2. So that gives me y as 8.2. That means what do I get? I can write that at the equilibrium E0 dash, the values of x and y are what? The values of x and y are 10, 8.2. So now I can sum up. We have calculated all the values. At the initial equilibrium E0, the values were, at the initial equilibrium E0, the values were 2, 9 for x and y. At E0 dash, which is the equilibrium with substitution effect, this was my initial equilibrium. At E0 dash, the values are 10, 8.2. This is equilibrium with substitution effect. Equilibrium with substitution effect. And at E1, the values were 10, 9, which is the new equilibrium. Okay, so I can now calculate the substitution effect for good x is going to be equilibrium value at E0 dash minus the equilibrium value at E0, which is 8. So plus 8 denotes my substitution effect for good x. Income effect for good x is going to be the equilibrium value at E1 minus the equilibrium value at E0. So 10 minus 10, which is 0. Okay. And what's the price effect? Price effect for good x is the sum of substitution effect for good x plus income effect for good x, which is The substitution effect is 8. The income effect is 0. So the price effect is 8. These are the answers for this question. Remember, movement from E0 to E0 dash denotes substitution effect, and the movement from E0 dash to E1 denotes income effect. And I've done a lot of practice questions based on this particular concept in my intermediate microeconomics part 1 course. Okay, so serious students who want to do some serious study of intermediate microeconomics part 1 are requested to enroll for my complete course for intermediate microeconomics part 1. However, in the next lecture series for this particular question paper, I'm going to solve part B. We are going to solve part B of question number 1 in the next lecture. So I stop in this lecture. I hope students have enjoyed this lecture. Any doubts, you can unmute your mics and ask, or you can get in touch with me for doubts on call or WhatsApp, or you can mail me your doubts at divineschoolof economics@gmail.com. This is where I stop in this lecture.